Okay, question number 1. F of x is equal 8 times x minus 6. So we need to find the domain of the function. So far we learned how to find the domain on the graph of the function. Now we have to learn how to find the domain based on given expression. So we have 8 times x minus 6. The key point here is that to be able to find domain, we have to have real numbers, which means those are real numbers make actually geometrical line, right? Any number here, be it positive, be it negative, be it whole number, be it decimal of number or fractional number, as long as it doesn't have imaginary number. We have real number. Okay, so if numbers are real, and then we have domain negative infinity, negative infinity to positive infinity. Exception, it's gonna make if we have division, and if we have a radical with some at the odd degree. I mean, not odd, I'm sorry, even degree. Even degree. Okay? Now, we don't have here division, and we don't have radical. Therefore, our domain is going to be from negative infinity to positive infinity. On the graph, since we have domain negative infinity, positive infinity, that means our graph is uninterrupted, right? Okay. Next one, question number 2. F of x is equal 8 over 13. X plus 13. Voila, here we have division, so we have to pay attention. We cannot say it's not going to be negative infinity, positive infinity, because we have division, and we cannot have division by 0, which means in this case x plus 13 cannot be equal 0, which means x cannot be equal negative 13. So let me explain. If this is my negative 13, so I can have all numbers. This is negative infinity. Sorry. Okay, let me make it better. Okay, and this is my negative 13. So this is negative infinity, this is positive infinity. So numbers can be all numbers from negative infinity to negative 13, excluding negative 13, and then all numbers from negative 13 to positive infinity, again excluding negative 13. Now, how to write down this in math? So it is going to be negative infinity all the way till negative 13. So to show that 13 is not included, we put parentheses. If it would include it, we would put square bracket, yes? And it's going to be from negative 13 till positive infinity. Let me clean this, I don't need to keep it, and move this up. Okay, so this is going to be our domain. Question number 3. F of x is equal 8 over x squared minus 16x and plus 63. Okay, we have division. So if we have division, I have x in my division, so I have to make sure my denominator cannot be equal 0, right? Because we cannot divide by 0. So what we do, similar way as in number 2 we did, we write down x squared minus 16x plus 63 cannot be equal 0. Okay, so using factoring of trinomial, because we have quadratic trinomial, and factoring, so whoever need to learn how to the factor trinomial, please find my video where I explain step by step, or I will put at the end of this video. So I will put the reference to that video so you can click on it and go watch it if you don't know how to do it. The bottom line is I have to find two numbers that multiplication will give me 63 and addition will give me negative 16. Shortly saying. So these numbers are going, since I have negative, sum is negative, that means multiplication is positive. So that means both numbers are going to be negatives, right? Because negative times negative is positive, and negative plus negative, we still get negative. These numbers are going to be 7 and negative 7, negative 9. Because negative 7 times negative 9, it's going to be 63, right? Negative 7 and negative 9, it's going to give me negative 16. So what do we have here? X minus 7 times x minus 9. Again, I will put at the end of the video how to factor trinomial, and you can go watch it. So from here, since it cannot be 0, that means either x minus 7 cannot be equal 0 because we have multiplication. Either first term, this first term cannot be equal 0, or the second term cannot be equal 0, okay? So either x minus 7 cannot be equal 0, which means x, which means x cannot be equal positive 7. I moved from here to here, right? Okay. And either nor x minus 9 cannot be equal 0, or x cannot be equal 9. So we have here two restrictions. Let's see. 7 and 9. See how many intervals it's breaking from negative infinity coming till 7, and then between 7 and 9, and then from 9 to positive infinity. And we are going to use parentheses to show that 7 and 9 are not included. Okay? So let's see, from negative infinity to 7, and 7 and 9, and 9 and positive infinity. Yes? Okay. Next one. Question number 4. Again, let me clean this and move this up so we have notation organized and would be easier for you to follow. Question number 4. Excuse me. F of x is equal 6 over x plus 14 plus 4 over x plus 4. Okay, we have two fractions, that's mean. For first one, x plus 14 cannot be equal 0, right? Which means x cannot be equal 14. Second, x plus 4 cannot be equal 0, or x cannot be equal negative 14, I'm sorry, cannot be equal negative 4. Let me clean, make it nice. Okay, x cannot be equal negative 4. So we have how many free intervals, right? So first one is going to be negative infinity till negative 14. Second one, it's going to be negative 14, negative 4, right? And then we will have negative 4 to positive infinity. Correct? Okay. Question number 5. We have f of x is equal 7 over x squared plus 25 minus 9 over x squared minus 16. Okay, so x squared plus 25 cannot be equal 0, which means, oh, actually, I'm sorry. I didn't see it, pay attention that it's addition. I thought it's subtraction. When it's addition, it can be anything, right? Squared, because we have x squared, so no matter what x is positive or negative or even 0, so we're going to get all positive or 0, right? At this point, there is no restriction in there. Correct? Okay. But different story, x squared minus 16. So let's see. X squared minus 16 cannot be equal 0, which means x squared cannot be equal 16, right? Once I'm moving 16 on this side, so negative will become positive, correct? All right. So x squared cannot be equal 16, which means x cannot be equal plus minus 4. And therefore, domain is going to be, see, I didn't put domain everywhere, letter D. Well, I can add it right now, okay. So domain is going to be negative infinity till negative 4, and then negative 4 to positive 4, and then positive 4 to positive infinity. Next. Question number 6. F of x is equal square root x minus 1. Remember what I told you. As long as all real numbers in the expression, excluding division, where x is present in the division, in denominator, or it's going to be radical with even degree, or which is square root also. Radical with degree 2 is a square root, right? So what is going to be here? Condition is going to be square root x minus 1 cannot be, has to be greater or equal 0, right? Or cannot be. Okay, if I raise to power 2 square, what I'm getting, x minus 1 greater equal 0, x greater equal 1, right? As long as it's 1 or more, which on the line of numbers, it's going to look like that. I'm going to fill with solid circle. That means it's included. 1 is included. It's going to be 1 or greater than. That's going to be our domain. So domain in this case, let me clean this. Domain in this case is going to be square bracket 1, because 1 is included, and all the way to positive infinity. Okay? Moving to question number 7. Here we are going to work with algebra over functions. We are going to do algebra over functions. Okay, question number 7. So we have f of x is equal 4x plus 2. G of x is equal x plus 5. So what do we need to find out? A. Find the f plus g. B. Find f minus g. C. Find f times g. And D. F over g. Okay. So, f plus g, it's equal f of x plus g of x, or since both of them are depend on x, right? X and x, then we can write down f plus g of x, and we have 4x plus 2 plus x plus 5. So like terms 4x and x, 2 and 5, we are getting 4x plus x, 5x, and plus 7. So this is my result, 5x plus 7. Okay. Now we need to find out the domain for this. We move a little bit down. For f plus g. So what is going to be the domain? Since we have 5x plus 7, there is no division, there is no square root, then it's obviously going to be negative infinity to positive infinity. And we have all real numbers, right? Next, we need to find f minus g of x equal f minus g of x. This is going to be f, where is my f? 4x plus 2 minus, since I'm going to do minus, it's going to change, right? X plus 5. Okay, well, let me write down minus x plus 5. Because I'm doing minus, I put x plus 5 in parentheses because it's going to affect the sign, right? So it's going to be 4x plus 2 minus x minus 5. This with this one with this one, like terms, it's going to be 3x minus 3. 3x minus 3. Those are all real numbers. Do we have division? No. Do we have square root? No, which means domain is going to be negative infinity, positive infinity. Next, we are going to do multiplication. So f of g is equal f g of x. So that is 4x plus 2 times x plus 5. Okay, so first we multiply this and this. So it's going to be 4x times x, 4x squared, plus 4x times 5 is 20x. And then 2 times x, 2 times 5, plus 2x, plus 10. Okay, like terms. And we get 4x squared plus 22x and then plus 10. Yes? Okay, so let's do domain. What is going to be domain? We have division with x? No. Do we have the square root? No. Therefore, it's going to be negative infinity, positive infinity. And lastly, this is we call algebra with functions. Addition, subtraction, multiplication, and lastly division. It's not a difficult topic, right? So again is equal f of g of x is equal. So my f is 4x plus 2 and g of x is x plus 5. Can I do any simplification? No, I can't. But it's going to affect my domain. Here we have division. So which means for domain x plus 5 cannot be equal 0, which means x cannot be equal negative 5. Yes? Okay, so domain for this case it's going to be negative infinity, negative 5, and negative 5, positive infinity. All right. Next one. Question number 8. What do we have? F of x is equal x plus 5. Okay. G of x is equal 5x squared. One more time, I would like to invite your attention. You see, both of them depends on x, same variable. If one would be f of x, the other one would be g of y, you could not do any algebraic operations. Okay? Has to be the same the variable. Okay, let's start again. Same thing. A. Oops. F plus g of x is equal x plus 5 plus 5x squared. Nothing special. And obviously domain is going to be negative infinity, positive infinity. We know why, right? No division with x and no square root. Next, b. F minus g of x. So f is x plus 5. You have to be careful. Since you have f minus g, then first you have to put f, right? And then put minus 5x squared. While for addition it doesn't matter, for subtraction, yes, it does matter, absolutely. Why? 3 minus 5 or 5 minus 3, it makes difference, right? And minus 5x squared. Okay. And the domain, it's going to be same way, negative infinity, positive infinity. See, we are going to do multiplication. F times g of x we're going to get x plus 5 times 5x squared. So let's multiply 5x squared times x, going to be 5x cubed, and 5x squared times 5, it's going to be plus 25x squared. And the domain is going to be again negative infinity, positive infinity. And lastly, division. F over g of x is equal x plus 5 over 5x squared. Oops. Five x squared. So we have restriction, obviously. So 5x squared cannot be equal 0, which means x squared cannot be equal 0, which means x cannot be equal 0. So our break on this function at the point of 0, so domain is going to be negative infinity 0, and then 0, positive infinity. All right, let's do much more interesting case. Last one. We'll do more interesting cases now. Question number 9. So f of x is equal 6 minus x squared, and g of x is equal x squared plus 2x and minus 8. And minus 8. Okay. So, f plus g. Of x is going to be 6 minus x squared plus x squared plus 2x minus 8. X squared is gone with this x squared and like terms, and we get 2x minus 2. So domain is going to be negative infinity, positive infinity. B, f minus g of x. Okay, it's going to be 6 minus x squared. Now, because I'm going to do minus, so which means every single term, it's going to flip the sign, right? Positive will become negative, negative will become positive. So let's see, minus x squared positive will become, oops, x squared was positive will become negative, plus 2x will be, which will be minus 2x, minus 8 will become plus 8. All right? Why this one is dancing? Went down, so let me put it up. Okay, so negative x squared, oh, both of them are negative, okay. Like terms, negative x squared, and 6 and 8 like terms. So we are going to get negative 2x squared minus 2x and plus 14. Yes? And in this case, well, domain is negative infinity, positive infinity. See? See, signora. Let's see what is in C. F times G okay, is equal. So 6 minus x squared, yeah, that's right, wish me good luck, I'm going to multiply the whole 9 yards, times x squared plus 2x minus 8. All right, let's get going. So 6 by this, by this, by this. So it's going to be 6x squared plus 12x minus 48. Next, this by this, by this. It's going to be minus x to 4 minus 2x cubed, and negative x squared times negative 8, it's going to be positive 8x squared. Okay, let's see what we have here to combine. So negative x to 4, there is only one, x to 4, minus 2x cubed. Now 6x squared, 8x squared, it's going to be plus 14x squared and plus 12x and minus 48. So we have a polynomial, entire 9-yard polynomial, but the domain is going to be easy, negative infinity, positive infinity. Question number 10. Honestly, I have enough of these algebras. But never mind, we'll take care of it. F over g of x is going to be, because we divide f by g, which means in numerator will be 6 minus x squared. In denominator, it's going to be x squared plus 2x minus 8, which means I'm going to factor it. Can I factor it the way so? No, it's not going to happen. I cannot, it's not going to work. So therefore, we are just leaving like that, and the domain is going to be, well, let's see, x squared plus 2x minus 8 cannot be equal 0, right? So from here, x plus 4 and x minus 2 cannot be equal 0, which means either x plus 4 cannot be equal 0 or x minus 2 cannot be equal 0. So x cannot be equal negative 4, x cannot be equal 2. Right, so domain is going to be negative infinity till negative 4, and then between negative 4 and 2, and 2 and positive infinity. So real quick, so whoever is confused, negative 4, positive 2. So this is negative infinity, positive infinity is coming till negative 4, and then breaking at the point of 2, and then from 2 it's going to positive infinity. All right. Now this one, it's same thing, but the case is going to be a little bit challenging, I believe. Let's do it. Question number 10. And I promise this is the last one, algebra over functions. So we have f of x, but I highly encourage you to watch this one because here is algebra going to be interesting. It's equal 6 plus 1 over x, see? We're getting into fraction here, and g of x is equal 1 over x. All right. So what we are going to have here, f plus g, oops, f plus g of x, it's going to be 6 plus 1 over x plus 1 over x. So it's going to be 6, since both have the same denominator, so 1 plus 1 is 2. 2 over x. And what is going to be domain? X cannot be equal 0, right? So negative infinity to 0 and 0 to positive infinity. Next, b, okay, 6 f minus g of x, it's going to be 6 plus 1 over x minus 1 over x. This is gone. Answer is 6. So what is interesting here? If I would have only this 6, I would put domain 6. But I cannot do that. Why? Because my original function has division by x, and I can't ignore it. So when I have division, it's only 1x there, then I have to have condition that x cannot be equal 0, right? X cannot be equal 0. Therefore, I have to consider that in my domain, even though f minus g over x is going to be just 6. So here, in the case of addition, it's I still have division by 0, therefore I didn't have to go back to original one. But in the case of b, because I have 6, then I still have to remember that I have here x cannot be equal 0 in original functions. Therefore, I'm going to consider it. I have to consider it, and it's going to be negative infinity to 0 and 0 to positive infinity. Actually, this x cannot be equal 0. I'm going to consider everywhere. Okay. Now, f times g. Of x, it's going to be equal 6 plus 1 over x times 1 over x. So what it's going to be? It's going to be, I'm going to bring this 6 plus 1 over x to common denominator. Yes? So what is going to be here? 6 plus x. 6 plus 1 over x. Okay, let me do drafting here. 6 plus 1 over x to bring to common denominator. So common denominator is going to be 6 at the x. So here I have x, but here I have to divide by x and multiply by x, right? To get to common denominator, because whatever change you do to denominator, you have to do same change to numerator. As a result, it's going to be x in denominator, and here I will get in numerator 6x plus 1. Therefore, it's going to be 6x plus 1 over x and times 1 over x. Therefore, it's going to be equal 6x over x squared, because we have multiplication. Then denominator multiply by denominator, numerator multiply by numerator. 6x plus 1, 6x plus 1 over x squared. Okay. So here automatically, since I have x squared, domain will be covered by this original condition, x cannot be equal 0, which means domain is going to be equal negative infinity to 0 and 0 to positive infinity. And lastly, d, I'm going to divide f over g over x is equal. F is 6 plus 1 over x. G of x is 1 over x. Okay, we need to divide. So 6 plus 1 over x, we already know, is 6x plus 1 over x, right? And we divide by 1 over x. So to remind you, 6 plus x 1 over x, it's the same thing as a 6x plus 1 over x. We already simplified there, brought to common denominator. Now if I divide, I will get 6x plus 1 times x, and here x times 1. So because I have division, so I did, there are two ways. So you either flip the second fraction, which is 1 over x, you flip and you do multiplication, or that's the way I like to do. I do, when I have division of two fractions, I do cross multiplication, which means 6x plus 1 times x, and excuse me, x times 1. All right? So x is cancelled with this x, and result is 6x plus 1. So once we have 6x plus 1, so per se, this 6x plus 1 itself would have denominator, would have domain negative infinity, positive infinity. But because this is a result of division, then we cannot ignore this condition. This condition, and because it's not equal 0, so I have to consider it. Okay, so domain is going to be equal negative infinity 0 and 0 to positive infinity. So what we can say, we learn from these fractional operations, that if you get result of algebraic operation, you get domain negative infinity, positive infinity, you still need to consider the restriction from original functions. Okay? Question number 11. All right. Now we are going to do composition. So question number 11. We have f of x that is equal 3x, and we have g of x that is equal x plus 5. Find the following function. It is going to be the composition. We need to find the composition of f with g. This circle meaning composition. Composition of f with g of x. Next, we need to find the composition of function g with f. And then C, we're going to find the composition f with g for the value of x is 2. And lastly, composition of function f, g of f, g with f, composition of g with f for the value of 2. Now, composition f of function f with g of x is not equal composition of function g with f of x. Why is that? What do we understand when we say composition of function f with g? We understand that you take the g of x and use as an x value for f, which is going to be f of g of x. So, which means this x we replace with entire g of x, which means we replace with x plus 5. Let me show you. And that's why here also, if I write down, it's going to look like g of f of x. So now f of x I'm going to, in the case of b, f of x I'm going to plug as a value of x for g. Let me make myself clear. They say it's better 1 times to c than 10 times to here, right? So what do I mean by this? F composition f of f, function f with g, it's equal f of g of x. So which means f of x is 3x, right? My f of x is 3x. All right? So 3, and instead of x, I'm going to plug this x plus 5. Because I'm plugging g of x, and g of x is x plus 5. There we go. And the result is 3x plus 15. Next, composition of g with function of f, which means my g of x is x plus 5, and wherever I have this x that I have, okay, I'm going to replace with 3x. So instead of x, I'm going to have 3x plus 5. All right, now I need to find composition of f with function g for the value of 2. Where is my f composition of with g? Here it is, which is this much. Therefore, I'm going to write down instead of 3x plus 15, instead of x, I'm plugging 2. This 3x of plus 15, right? So 3 times 2 plus 15. So 6 plus 25 is 21. And the g of the composition g with f is, we have this result. So now I'm going to this 2 plug in this 3x, 2 plus 5, which is going to be 11. Okay, let's do another one. So you can kind of get used to it. 12. We have f of x is equal 3x minus 4, and g of x 5x squared minus 4. Okay, for a, we need to find composition of f with g of x. So which means f is 3x f of x is 3x minus 4. So 3 times, instead of x, I'm plugging the value of g of x, which is going to be 5x squared minus 4. See, kind of jumped. Let me fix it. I don't want to jump. So it's equal f of g of x, right? Which means 3 times 5x squared minus 4. B, f minus g the composition of g with f. So now we're gonna do g with f composition. So where is my g of x? It's 5x squared minus 4. So 5 times, so instead of x squared, it's going to be 3x minus 4 squared. So this 3x minus 4, I'm plugging 2 here. And minus 4, this is this 4. So what we're going to get? 3x minus 4 squared, I'm going to apply formula a minus b squared, which is equal a squared minus 2ab minus plus b squared. For the students, for the people who don't want to remember this formula, you don't want to use shortcut, then you can go ahead and open multiply two parentheses by each other, like 3x minus 4 times 3x minus 4. Okay, you can do this way also. It just you're still gonna end up to what we have. Now my a is how much is my a? 3x, and b is 4. So if I start opening these parentheses, I have a squared, which is going to be 3x squared, and then minus twice here 2ab minus 2a, which is going to be 3x, and b is going to be 4, and then plus b squared, which is 4 squared. So we get 3x squared is equal, 3 squared is 9, x to power 2 squared, minus 2 times 4 is 8, 8 times 3 is 24, x, and plus 16. So what do we get here? 5 times, let me move this higher. Okay, and I can continue right here. So I'm going to plug 5 times. Instead of 3x minus 4 squared, I'm getting 9x squared minus 24x plus 16, and then minus 4. Okay, let's simplify. So this is going to be 45x squared. This is going to be 5 times 4, 20, 5 times 2, 10, and 220x, and then plus 5 times, multiplying this one, 5 times 6 is 30, 5 and 3, 80 minus 4. So result is going to be 45x squared minus 120x and plus 76. That's the result. Look what a big difference. What a big difference. So in this case, f of g of x, that's mean when the value of g of x you plug to here, and you get 3 times 5x squared minus 4. Although you could multiply this. Let me clean this. So it's gonna be 15x squared minus 12, right? Okay. And for the case of a function g with composition of f, this one, it's going to be this result. See? we're gonna get composition of function f with g for the value of let's say 5. It's gonna be equal, where is function f with g? Here it is 15x squared minus 12. So 15 times 5 squared minus 12. So 15 times 25 minus 12. So 15 times 25. Well, multiply 25 times 15. 5 times 5, 25. 2 in mind. 5 times 2, 10, and 2, 125. And here is 25. 5, 7, 375. 375 minus 12. It's going to be 5 minus 2 is 3. 7 minus 1 is 6. And 363. Okay. And lastly, the function of g, composition of function g with f for value 1, which means everywhere I'm plugging 1. So 45 times 1 squared minus 120 times 1 plus 76. And we get 45 minus 120 plus 76. Okay, that is equal 100. It's going to be negative. First of all, 45 minus 120, it's going to be 10 minus 5 is 5. 11 minus 4 is 65. 65? No, 75. Looks like I'm tired. 75, and then plus 76, it's gonna be 1. I decided to split this video into 2 videos. So total there are 20 questions. So I solved here 12. In next video I will continue from 13 to 20 questions. Okay, see you in next video. Bye.